We now rewrite this given trigonometric expression over a common denominator. So we identify that in the first expression we have the denominator cos theta, and in the second rational expression we have the denominator sin theta. So therefore the common denominator is basically the product of these two terms, that is sin theta and cos theta. And this means for the first fraction we have to multiply and divide by sin theta. So let me do that. So I write down this first trigonometric expression, that is sin theta plus cos theta over cos theta, and this we have to multiply and divide by sin theta. So let me do that. And for the next fraction we have to multiply and divide by cos theta, that is I put this negative, and this is sin theta minus cos theta. This is over sin theta, and this should be multiplied and divided by cos theta. Now let's simplify this. So here we have this numerator term. So these two has to be multiplied, as well as the denominator terms has to be multiplied. And same thing we do for the next term, that is multiply the corresponding numerators as well as the denominator. So when we do for the first fraction, we will get sin theta plus cos theta, and this should be times of sin theta, and this is over denominator. If you multiply, we'll get cos theta times sin theta, which can be written as sin theta cos theta. We then have a negative, and let's multiply the numerator of the second term, that is we have sin theta minus of cos theta. So these two has to be multiplied with cos theta, and this is over sin theta multiplied with cos theta. We get sin theta and cos theta. Now we see that we have the common denominator sin theta cos theta, and this means we can combine as a single fraction. So I'm going to write down this term, that is this is the numerator term in the first expression, which is sin theta plus cos theta times of sin theta, and then we have this minus, so I put this minus. Next we have to write down this expression, that is sin theta minus cos theta times of cos theta. So when we do that we get sin theta minus cos theta, and this should be multiplied with cos theta, and this should be all over by the common denominator, that is sin theta and cos theta. Now we can do the distribution for both terms in the numerator. So I'm going to distribute this sin theta as like this, and so let me do that. So when we multiply sin theta with sin theta, we get sin square theta plus now multiply sin theta with cos theta, we get sin theta cos theta, and then I put this negative. Now I will have to multiply this sin theta with the cos theta. I get sin theta cos theta, and then cos theta with negative cos theta, I will get negative cos squared theta, and this should be all over sin theta cos theta. Now let's expand the second term. We have a negative, that is we will expand the bracket from the second term. So I write down the first two terms as it is, that is sin square theta plus sin theta cos theta. And then we basically have to distribute this negative into the two terms inside the bracket. So negative, we can consider this as negative 1. So negative 1 times of sin theta cos theta is negative sin theta and cos theta. And then when we distribute this negative with negative cosine square theta, we get positive cos square theta, and this should be all over the common denominator sin theta cos theta. Now I'm going to use the Pythagorean identity, that is I combine these two terms. So I write down as it is, which gives sin square theta plus cos squared theta. We also see that we have these two terms getting cancelled because this is positive sine theta cos theta and this is negative sine theta cos theta. So these two terms gets cancelled, and finally we are left only these two terms, that is sine square theta plus cos square theta, and this is all over sine theta and cos theta. And we know that according to the Pythagorean identity, that is sine square theta plus cos square theta, this is equal to 1. So this is one of the Pythagorean identity which we will utilize here. Therefore, we can replace this complete expression using the Pythagorean identity, and so this equals 1. So we get 1 over the denominator, that is sine theta cos theta. And so this is the final expression in terms of the common denominator, that is 1 over sine theta cos theta.